Here we have our notes. Here. Can you see the screen? All of
Yes,
you?
sir.
Yes,
Yes,
sir.
sir.
Bangla class na?
The physics class. কই বাংলা ক্লাস
Airport. I said airport.
এয়ারপোর্টটা বলো নাই তুমি তোমার
Airport আমি বলেছি হয়তো মাইক মিউট হয়ে গেছে।
Yeah. Might be there is missing one word due to network. Yesterday it was a problem in network, right?
নেটওয়ার্ক না আমি
Yes,
স্পেস বার
sir.
দিয়ে মাইক অন করি তো আমি আর মাউস হাতাই না তাই এজন্য দেখা যায়
Okay,
মধ্যে মধ্যে হাত ছুটে যায় আর কথা শোনা যায় না।
So the last paragraph, I ask you to read again this one. Adnan, can you read the last one? The heat released by fission.
The heat
Hello?
released by fission in nuclear reactors must be captured and transferred for use in electricity generation. To this end, reactors use coolants that remove heat from the core where the fuel is processed and carry it to electrical generators. Coolants also serve to maintain manageable pressures within the core. Life of stars. The
Okay,
birth of a star begins when...
wait. We are done with this part, right? Nuclear fission and fusion. Okay. Though we did not discuss fusion in details, we had some idea about fusion. But nuclear fission, we discussed everything. We discussed also the nuclear power station, how we are getting electricity there. You see there is block diagram and we are using their control rods, we are using their moderators, and also we are using their coolants. All these things we discussed today. Okay, so Yakin, as you are not present in the first lesson, I suggest you to go through the recording. Okay.
Yes,
Yakin,
sir. I'll go through the
please,
recording.
yeah, please go through the recording and you'll understand everything, inshallah. And if even after that you have any queries, you can ask us next class. Okay, now we are
Inshallah,
starting life of stars. Life of stars. Actually, here we are not going for details or much deeper. Just the little bit idea we'll get here, and mainly we'll focus in nuclear fusion. Okay. I brought some idea here how it is happening in life of stars, or how the stars is working for fusion. So this one here we'll get life cycle also of stars, then supernovas. We got here nuclear fusion. So this one is most important, nuclear fusion part. The other things we are giving mostly extra. So just go through. Yakin, you read life of stars. Yakin, read please.
The birth of a star begins when massive clouds of dust and gas start to collapse and break down. How does this happen? It happens to a force of gravity. Gravity bonds are
Bounds.
elements to bounds the elements together to create a protostar. The protostar is basically a baby star and grows into a star through its life cycle. In same way, we are born and grow. The main process of all stars' birth is called nuclear fusion. Nuclear fusion happens in a very large cloud on gas called nebula, which nuclear fusion starts in a nebula and reaches temperature of over 10,000 degrees. The star begins to form. The new baby star that, as we know, is called a protostar. Gravity continues to play a part in the star's birth control and continued life. The mass of star determines the color of star, allows scientists categorize the type of star. Scientists can then also try and confirm the amount of energy the star can give off.
Okay, very good. Thank you. Now, look, here we are using some terms like when Yakin was reading this part, it happens through the force of gravity. Then you could ask me that how it is working, the gravity, how it is working. That's why I gave this sentence. Gravity bonds the elements together to create a protostar. When you got this word protostar, you could ask me what is protostar. Then I gave this sentence that the protostar definition I gave, and a little bit discussion how we are getting the protostar. So this part I tried to make in a way that the queries you can ask me, those also answered here. Do you understand what I'm saying? Hello?
Yes, sir.
Yes,
Yeah,
sir.
yeah. So if you again go through the notes only, I think you will understand it. We do not need more details on this. Then continue, Yakin.
Sir, shall I start from
Yes, yes, yes. From there.
let us look into the life of a star and the stages star goes through until death. These things are called life cycle and supernova. Life cycle equals to life of a star. Supernova equals to death of a star. Stars do not live forever. They live and die just like us. Although after its birth, the star lives for a very long time before its death. The time and the type and mass of a star will determine how long the star will live for through its life cycle before the star goes supernova.
Very good. Very good. So continue here. Life cycle.
Life cycle through nuclear fusion, the star is born, and what happened through the star's life depends on the size of the depends on the size of the star when made. What we know happens to all stars is when the hydrogen gas runs out, which causes the star at its core to collapse. The star starts to use the helium gas and other elements.
Okay. So uh, till here we got some ideas that what we know happens to all stars. That means all the stars uh, they are using the hydrogen gas. Hydrogen gas runs out, which causes the star and it core to collapse. The star starts to use the helium gas and other elements. So when hydrogen converts to helium, right? This helium is stored over there. Hmm. You see, through nuclear fission, the star is born. So nuclear fusion means we will go for more details. That two hydrogen atoms they are combining together, joining together to form heliums. Those helium are here available in star. Then continue here, please. Yeah, continue.
Star becomes larger and larger over time and then burns out all its energy, leaving just the core. The star is still alive and is still very hot. Over millions of years, the star cools down again depending on the type and mass of the star. The star can go supernova and die in a big explosion where the core is torn apart, or can go very cold and stop to burn any energy.
Okay. So here we got supernova, right?
Yes,
Supernova
sir.
is the you got here at the beginning death of a star. So by doing supernova, star is dying with big explosion, and there we get the core of the star torn. apart, or can go very cold and stop to burn any energy. And after supernova, we are not getting any more energy. That means the form of energy we are getting from sun, mainly heat energy, right? Heat energy and light energy. So after supernova, we are not getting that energy anymore. Our sun is also one star. One day it will also get supernova. And what will happen to us then?
Sir, will be sucked into the black hole.
Yeah,
The sun will break down, turn to a black hole, wouldn't it?
yeah. That time, you see, black hole. What is black hole actually? Do you have any idea about black hole?
Black hole
Black
is
hole
a
holds
type
the
of an
most
antimatter.
density.
What happens in black hole actually? Why it is black?
I don't know
The
why.
It's a
basic
type
idea.
of
Only
an
give me the
antimatter.
basic idea.
বেসিক আইডিয়া যেটা নরমালি বেশি বলে হচ্ছে ইট সাকস আপ এভরিথিং,
It sucks everything up.
কিন্তু আমার মনে হয় না এটা সাক করতে পারবে, কারণ লাইটের তো কোনো ম্যাস নাই। সেই জন্য যে অনেকজন বলে ব্ল্যাক হোলের গ্র্যাভিটি অনেক, কিন্তু লাইট তো ফোটনস,
This one.
ফোটনস কিভাবে টানবে?
না, ব্ল্যাক হোল কিন্তু অনেক হাই ডেন্সিটি আছে, তার মানে হচ্ছে গ্র্যাভিটেশনাল ফোর্স অনেক বেশি। সো গ্র্যাভিটেশনাল ফোর্স
গ্র্যাভিটেশনাল ফোর্স যদি আনলিমিটেডও থাকে, লাইটকে তো টানতে পারবে না। লাইট তো ম্যাসলেস, লাইট তো ফোটন। তাহলে কেন বলে ইভেন লাইট ক্যানট স্কেপ?
না,
লাইটকে টানার কথাও কি ওটা তো একটা ব্যাপার।
acha, light from where the light is coming? Light is coming as the form of photon, fine, but you have to produce light first, right? Then light will come. If the things which are producing light, that is stopped or that is attracted by the black hole, that is taken by the black hole, then light cannot be produced. Then how come light will come out or light will produce?
Plus, light is indirectly or technically sucked in by
Yeah,
the black hole as well.
indirectly they are saying that it can also stop the light. That means light is there is no condition to produce the light. That's why we are not getting any light from there.
ব্ল্যাক হোলস আর কি, গ্র্যাভিটি যখন হয় এটা মানে ডিপেন্ড করে এগুলা কোথায় নিয়ে যায়, এনার্জি কোথায় ট্রান্সফার করে।
Energy, they actually whatever is surrounded by the black hole, it takes in everything. Okay, like the hydrogen is responsible to do the fusion process, right? Isn't it? And
Yes.
if your hydrogen is taken by the black hole, if your helium is taken by the black hole, then how can this process will continue, right? And that is the logic. So at least you could say one thing, that the black hole has a high gravity, right? And that's why we are not getting any light from there, any heat from there. That's why
স্যার যদি আর্থের কোরও যদি বের করে আনা হয়, ধরেন একটা প্রসেস আর্থের কোর বের করা হয়েছে, ওইটারও তো অনেক হাই গ্র্যাভিটি হবে না ব্ল্যাক হোলের ইকুইভ্যালেন্ট? কারণ
No
সান,
way.
আচ্ছা না আর্থ না সান, লেটস সে সানের কোর বের করে আনা হইলো, কারণ ওইটাও তো আলটিমেটলি একই জিনিসই হবে, তাই না?
Nah, not even a million years. Sun-এর
কেন না?
যত gravity আর density আছে, it's not even close to the black hole, because black hole is
তুই
infinity.
ব্ল্যাক হোল কি তুই
According
জানিস?
to
যখন একটা
science,
স্টার মারা যায় তখন ব্ল্যাক হোল ফর্ম হয়, as far as I know at least.
হ্যাঁ,
না,
সানটা যখন মারা যাবে তখন ওইটা ব্ল্যাক হোল ক্রিয়েট করবে।
শোন, সানটা যখন মারা যাবে তখন
let us
স্যার শোনেন,
continue.
হাইড্রোজেন ওই যে সব শেষ হয়ে যাবে, মানে উপরে যেগুলো আছে সবকিছু শেষ হয়ে যাবে, দেন কোরটাই তো বের হয়ে আসবে। এন্ড যেহেতু কোর তখন তো অনেক বেশি হবে গ্র্যাভিটি।
Is it coming out? The core is coming out.
হ্যাঁ হ্যাঁ, ওইরকম কিছু একটা।
Okay, we will discuss it later on. Now, supernovas. We are discussing a little bit. Then you'll get some more ideas, hopefully. Can you continue, Adnan, this part? Supernovas.
Supernovas. Supernovas are extraordinary events altogether and have been witnessed and recorded by scientists. As there are so many stars in our galaxy alone, these supernovas are common. So if the star does not quietly die out, the star will die out a very violent death by the way of supernova.
Okay, so here we gave some link, the video, the one we already discussed. Here you will get little bit more in the discussion in these videos. If you are more interested, then you can go through these videos, and after that we can discuss on all these things you asked me about, the black hole mainly, and you have different ideas about the black hole. So please go through this video if you have more interest. And for our O levels, whatever I gave, that's enough. And whatever we discuss, those are more than
এসব
enough.
স্টারফার, আচ্ছা স্যার, এসব স্টারফার ও লেভেলের জন্য আছে নাকি?
No, no, no. Only I gave these things to have
As
some
examples.
ideas. For have some ideas. We don't have all these things in your O level syllabus. Just you have to know that we have fusion in stars. Okay, that all you know, right? We are getting the heat energy, light energy from the fusion process happening in the stars. Now you get here nuclear fusion. Nuclear fusion. This is important for us. Okay, then we'll go to half-life. Yeah, Aisha, please continue. Nuclear fusion.
Okay. Nuclear fusion. Fusion is a nuclear process where energy is produced by smashing together light atoms. Fusion is the process by which the sun and other stars generate light and heat. It is most easily achieved on Earth by combining two isotopes of hydrogen, deuterium and tritium. For a nuclear fusion reactor to occur, it is necessary to bring two nuclei so close that the nuclear forces become active and glue the nuclei together. Nuclear forces are small distance forces and have to act against electrostatic forces where positively charged nuclei repel each other. This is the reason nuclear fusion reactions occur mostly in high density, high temperature environments.
Okay, so we need some conditions for nuclear fusion, and that is the reason in our Earth that condition we are not getting so easily. That's why it is not easily possible on Earth. The fusion is becoming very tough and very expensive. That's why when it will be easier, or the scientists are working on it, it will be more cheaper to do this process. That time they will do fusion reactor also, where we can get lots of energy, because we have this supply of water, we have lot. And if anyway we can successfully do nuclear reaction, that is fusion power station, if we can somehow make it, then we will have abundance of energy. We will not have any worries about energy. Okay, because we have enough supply of water. So from water we'll get this deuterium, tritium, and uh, that will help us to do the fusion process. You see, here I give one reaction, deuterium, that is H2, then tritium, H3, they are combining together, and this is transition state. You see, three neutrons and two protons are combining together. Then finally, we are getting alpha particles, and we are getting one neutron. So, alpha particle means helium-4, right? Hello?
Yes,
Hello?
sir.
Yes, alpha particle is helium-4, and in this deuterium, we have electron also, right? Here also we have electron. So when we are having here two electrons with this alpha particle, then it is helium. Is it clear, everyone?
Sir, then is
Yes,
that a
sir.
helium nucleus or an helium atom?
This one is actually helium atom. The nucleus is working like alpha particle, but we are actually getting helium, formation of helium here. Is it clear?
Yes,
Hello?
sir.
Those two electrons here, they will stay here, and we are actually getting helium atom over here, and one extra neutron over there, that is free neutron with 14.1 mega electron volt energy. Mega electron volt, it is uh, the energy unit. You know joules, right? Energy unit is joules. And in molecular level, we are using this in electron volt. The joule we are using in bigger scale, but in molecular level we are using this unit as electron volt. In A levels, we will show you how to convert joules to electron volt. Okay, you know one thing. That acceleration due to gravity, G. What is the unit?
For Earth, isn't it 10?
Meter per second. The unit. I ask you the unit.
In
Meter per second square. Okay, acceleration due to gravity. The same thing is known as also gravitational field strength, right?
yes, sir.
And when it is gravitational field strength, we are using this unit,
Newton per kg.
Newton per kg. So Newton per kg and meter per second square is equivalent, same thing. Do you understand?
Yes, sir.
Okay, so similarly, joules and electron volt, they are similar unit. There is some numericals value. 1 joules equals some amount of electron volt. That one we'll discuss in A level how to convert. Okay, now just remember that this is similar to joules. Okay, this is unit of energy. Sometimes you might be confused at what it is, mega electron volt. That's why I brought this idea. Okay, now we are going to next part. Yeah, fusion, the one you got before, it is deuterium and tritium. Now you are getting also fusion this way: hydrogen 1, hydrogen 2. Then here we are getting how many protons? One proton,
One
one
proton, one
proton, one neutron, and here no neutron. So they are combining and they are making two protons, one neutron combining, and we are getting helium-3. It is one of the isotopes of helium. So fusion can be these two types. Is it clear? Hello,
Yes,
Yeah.
sir.
everyone.
Yes,
And
sir.
yes, there is another way to have fusion. That is 4 hydrogen. You see, that is 4 protons. Okay, 4 protons are there. So 4 protons are combining here. They are producing helium, right? Do you understand it? How this process is happening?
Yes.
Yeah, if you are getting here,
No, I don't understand that one.
yeah,
I don't
you don't
know.
understand. Yeah, it's I wanted this question. You don't understand. Thank you. Look, here we got some extra neutrons, right?
Yes, sir.
Okay. So these extra neutrons, they can help to get this helium. Got it now? These extra neutrons will go there and they will help us to get. Here they are showing, you see, they gave only one arrow. They did not give equal sign. That means we did not, balance the equation. Here we are showing only one helium. Actually, if we have 4 hydrogen plus 4 neutrons, then we will get 2 helium atom. Then the equation will be balanced. Is it clear what I said?
Yes, sir.
Yes.
Sir, how will the other, if there are 2 helium atoms, then there should be 8 hydrogen, right?
No,
Because
no,
it has
no,
a mass
not,
of 4.
no. It's not 8 hydrogen. It's 4 hydrogen, 4 protons. Okay. Then if you have
Yes,
4
sir.
neutrons, then you are getting 2 heliums atom.
Oh,
Because
yes,
2
sir.
heliums means 2 to the 4, 2 4 the 8.
I still don't get it.
Is it clear now?
Yes, sir.
Okay. Okay. So here we did not need to explain so much. Just for your confidence, I explain this matter because sometimes you will see it and you'll be confused how the neutrons are coming and how it is forming the helium. So can you read this part, please? Ziba.
Yes, sir. Process of nuclear fusion with different isotopes of hydrogen colliding and fusing to make helium. There are a number of different nuclear fusion reactions happening in the Sun. The simplest is when 4 hydrogen nuclei becomes 1 helium nuclei. The combined mass of 4 hydrogen nuclei is 6.693 into 10 to the power minus 27 kilograms. The mass of one helium nucleus is 6.645 into 10 to the power minus 27 kg. This means there is a missing amount of mass equaling 0.048 into 10 to the power minus 27 kg. The missing mass is converted to energy which radiates away according to E equals to mc square. This is seen happening in the Sun.
Okay, this one I told you maybe 3 or 4 times. There is mass defect when you are getting the nuclear reactions in between the product and the supply. The supply and product, there is a mass difference. Do you understand what I am saying? The supply is here hydrogen and the product is helium. In between these two, there is a mass defect. There is difference in mass. Okay, so that one is called mass defect. This mass defect helps us to get the energy. We are getting simply one equation. We are getting simply one reaction. But where from we are getting the energy? The energy is coming from that mass defect. The light energy, the heat energy we are getting, those are coming following the equation equals mc square, where m is the mass we got as difference, the difference between the product and supply. That mass, when it gets the speed of light, then we are getting energy. This energy is coming out as heat energy and light energy. Okay, the more mass defect we are getting, the more will be the energy coming out, right? To get more mass defect, we need more reactions. Okay, the sun or the stars, which has more reactions, more fusion reactions, that one has more light energy, more heat energy. Is it clear, everyone? Hello?
Yes, sir.
Okay.
Yes,
Yes,
sir.
sir.
Okay, now we are very close. I think another day we will start half-life. Okay, we are now
Inshallah.
Yeah, we are now summing up today whatever we did. We started our class today from nuclear fission and fusion, and we discussed details on this fission, and afterwards we have the idea about control and uncontrolled chain reaction, nuclear fission, and how to control them using the moderator control rods, and how to use coolants to get the energy, better coolants. Which one is better coolants? That one will use. That one will absorb more heat energy and get more electrical energy. And afterwards, we got life of stars, a little bit, not so much. And life cycle, briefly life cycle. We had supernovas, death of star. Finally, we had nuclear fusion. And at least today you understood that nuclear fusion from this part, that is previously you might have that it's always happening that you thought from hydrogen to helium directly it's happening. But it can be happening in three ways. This idea may be new to you, right? All of you? Hello?
Yes, sir.
Yeah, nuclear fusion, it can be happening in three ways, and there I brought these three equations or three processes, and you could um, sum up, or you could linked with your ideas you had before, and I think you also enriched today, right? With all these discussions. Hello, hello.
Yes, sir.
Yeah. So thank you so much for joining and being party secretary, all of you. And I want your cooperation. I want your cooperation to invite your friends in class. You have some other friends who are joining in other classes. Uh, Maybe Liban is joining in other classes, right?
No, sir,
No,
sometimes.
Yeah, then you have
this
some
week
other.
he didn't.
Shomik is joining in other classes.
সৌমিক না সায়েন্স ছেড়ে দিয়েছে
Yes.
Okay, so
We,
if you have anyone, they are doing classes. Maybe in the morning they are not, comfortable to join. You please request them, huh? Invite them to join the classes.
sir,
I think
what
they
can
will
we
be
do if sleep is more important, right, sir?
no problem, no problem. You just tell them. They, inshallah, they will be benefited if they join. Okay. Okay. Allah Hafiz.
Assalamu
Allah Hafiz,
alaikum,
sir.
sir.
Salam. Thank you so much. God
Allah
bless
Hafiz,
you.
sir.
Allah Hafiz.